All right. So today's lesson is going to be about polynomials. And there's certain things that you learned the last couple years in polynomials. And we're going to review a couple of those topics here to help you be more efficient with your homework. First thing I want to talk about is what do you do when you have a fraction? Let's look at something really quickly, because I want you to understand what it means to have a fraction like this. Okay? This says 4x plus 8 divided by 2. Would you say that that means the same thing as half of 4x plus 8? I mean, of course, dividing by 2 means multiplying by a half. And when we have a half out in front of the parentheses like this, we're going to distribute. We use the distributive property, and you say half of 4x is 2x, and half of 8 is 4.
Can you scoot the screen over a little bit, please, like the paper?
Let's see here. Do you see it or no?
No. It's like,
Yeah, it's totally showing up on my screen, but it's not showing up on the other one. Hang on. Did that? No, yes. Do you see it now?
yeah, that's a little bit better. But I can only see like the problem. I can't see the whole thing.
Okay. Are you on a computer or on your phone?
The computer.
How about now? Can you see the whole thing?
Yes.
Okay. You might want to zoom out. You might be zoomed in too much on your screen. I'm not sure. Okay, so I have the 2 here, and we did 1/2 of 4x plus 8, gives us 2x plus 4. I could just distribute the 2 to each of these. Whatever's in the denominator goes to the each term of the numerator. So now I can see 4x over 2 is 2x, and 8 over 2 is 4. Okay? How about if you had something like this? 6x plus 5 over 3. Well, I can give the 3 to the 6 and the 3 to the 5. This over here reduces to 2x, and this is 5/3. Sometimes we will still leave the answer in this form. I just want you to see how the distributive property operates when you have a number down here. Okay? Next thing. What happens when you have a minus sign out in front of a binomial that has a subtraction sign? If I were to distribute the negative sign, which is like distributing -1, I would get -x, and I would get +8. I could rewrite that as 8 minus x. So when I have a minus sign outside of a difference, all I do is flip them around and leave the minus sign. Let's do another example. 12 minus 2x. Well, that's 2x minus 12. Check it. -12, there it is. -2x, which is +2x. There it is. Sometimes you'll have something like this. 4x plus 18 divided by, restart, 4x minus 18 divided by -2. Well, I can give the -2 to each one, but the minus sign right away is going to make me flip it. Now I can divide each term by 2. And I get 9 minus 2x. You can still do it the long way as well. You can distribute the negative 2 to each term, and you're going to get the same answer. Any questions? Take a screenshot because I'll go to the next page. Be sure you're paying attention to what I present and not trying to catch up on notes. You can catch up on notes using the YouTube videos afterwards. Okay. Next up, what do you do when there's parentheses? And what do you do about combining like terms? Well, what are like terms? Like terms have two different things. One, they have the same variables, and they have the same powers of those variables. Same variables and same powers of those variables. We combine like terms using the distributive property. 3x squared plus 8x minus 2 plus 10x minus 5. A way to do this is to, sorry, a way to organize yourself is to start with the highest power, the 2, and underline it. Now underline any other x squareds you see. I don't see any more. So I'll just write it down here. The next highest after the second degree term is the first degree term, and I'm going to double underline those. And I'm going to combine them. Positive 8x, positive 10x. When I add them up, I get positive 18x. Finally, I've got my numbers left. I got my constants, negative 2, negative 5, gives me negative 7. The reason for the underlining is because sometimes you have a long line and you might miss a term. If you underline them, you know exactly which ones you've done, and you can see if you've missed one. This was taught to me when I taught middle school. An 8th grader taught me this. Her 7th grade teacher taught her to do that way. Okay, what do we do when we have numbers in front? Okay. Well, in order to combine like terms, the first thing you have to do is get rid of the parentheses. And we do that by distributing. Let's distribute the 4 to each term here. And I'm going to get 12x squared plus 48x minus 4. On this one, we have to distribute a negative 40. So I get negative 80x squared plus 40 times 12 is 480. Is that right? Yeah. Okay. Now we go through the same process as before. My x squared terms are the highest, so I'm going to underline them one time. Positive 12x squared, negative 80x squared. That gives me negative 68x squared. The next terms are the x terms. There's only one of them. Copy it down. And then my constants, 480, take away 4 is 476. You can go back and verify that more slowly if you need to. Any questions? Take a screenshot if you need it. Okay. Next up, we have multiplication, and there's many ways people learn to multiply polynomials. As dull or whatever you want to say as it seems, no method beats the box. Let's say I have 3x squared minus 2x plus 1, and I'm going to multiply it by 8x plus 5. The best way to do this is to make a multiplication table and then to combine like terms. So I've got 3 terms on one of my polynomials and 2 terms on the other. I'll write my 3 terms along the 3-term line. 3x squared minus 2x plus 1. 8x plus 5 goes on the side. And now I just multiply. What's 8x times 3x squared? 8 times 3 is 24. X times x squared is x cubed. 8 times negative 2 is negative 16. X squared. 8x. 5 times 3x squared is 15x squared. Negative 2 times 5 is negative 10x. And 1 times 5 is 5. What's cool also about the box is normally the like terms, normally, not always, normally the like terms are along the diagonals. Okay, 24x cubed. 15x squared minus 16x squared. Don't put a negative 1x squared. That's negative x squared. Negative 10x plus 8 is negative 2x. And 5 is plus 5. There you go. I multiplied a trinomial by a binomial. Okay, a couple of shortcuts you need to know really quickly. One of them is the difference of 2 squares, which we did yesterday with the conjugates. If I have an a plus b, a minus b situation, the answer is going to be a squared minus b squared, which is the difference of 2 squares. X times x is x squared. 3 times 3 is 9. Put a minus sign between it, and you're done. That's the difference of 2 squares, when one of your binomials has a plus and the other one has a minus. But be careful. Sometimes they both have the same sign, and that's completely different. This one is the same as x minus 3 squared. Now, you can still do the box. You can also memorize the pattern. The pattern is first one squared, and then minus 2ab. So 2 times x times 3 is 6x. And negative 3 times negative 3 is plus 9. I don't expect you to remember that. But I'll tell you a trick that my pre-calculus teacher taught me in high school, because it was the only thing I learned from her the whole year. When you square a binomial, it has to be 2 terms. Here's how you do it. You square the first term. Square the last term. And now multiply everything you see. I see 2 times negative 3 times x. 2 times negative 3 is negative 6. X. There it is. The same. If you don't like all of that, do the box. And we're going to see where this stuff comes from. Right here is squaring the first, x times x. Down here is squaring the last, negative 3 times negative 3. So we see the square the first and square the last. Now, multiply everything you see means doubling this times this. 2 times this times this. Well, negative 3 times this is negative 3x, and x times negative 3 is negative 3x. You can see where the doubling comes from. It's right there. That's why we get negative 6x. Do I have any questions? Going once, twice. One last example. What if you had something like this? Somebody tell me what we have to do first to do this problem.
Distribute.
What do you distribute?
The 2.
The 2. So be careful because distribution is multiplying. And yes, Vanessa, we have to do the expanding, if you want to call it that. We do have to do the exponent first, but that's not called distributing. Distributing will be later with this minus sign. So let's do the first step being the exponent. I'm going to leave everything else the same. And to do this exponent, you square the first, square the last, and multiply everything you see. 2 times -4 times x. Next, we're going to distribute the minus sign. There's nothing here except for an invisible 1, so I can just rewrite this. And distributing the minus sign, I get minus x squared plus 8x minus 16. Underline your x squareds and add them. You get 0. Double underline your x terms and add them. You get 14x. Triple underline your constants and add them. You get -18. In my past, I've had people say, what do you mean an atom? Subtraction is just adding negative numbers. I can say adding them every time. Want to see? I see 2 numbers there. I see 6 and -2. Add them. 6 plus -2 is 4. Okay. Let me go ahead and turn off the record function because we are done here.